Welcome everyone. Welcome to my channel in YouTube. In this video, I am going to teach you how to use Docker to containerize a Python application for data analysis. And I am also going to teach you how to implement continuous integration with GitHub Actions and continuous delivery with Dockerhub. Now, please let me share my screen. This is an example of a code written in Python for data analysis. Its name is anagrams. Let's examine the source code. This is the main Python script. Here we have the code. So as we can see, it's a Python script that will take a list of words from a dictionary file, separate words into classes of words with the same length, and for each class of words of the same length, we'll find all anagrams. And in the end, it will count the total number of anagrams in each class. The most important line here is line number 17, because it specifies what is the file that is going to be used to get the words from the dictionary file. So words.txt is the dictionary file that is going to be used throughout the program. This folder, data, contains the file words.txt. If we open it, we can see the content. The content, as you can see, is a normal dictionary file with thousands of words. These thousands of words will be examined, analyzed, and checked for anagrams. And in the end, as the source code is already described here, it is going to show us, it is going to print the total number of anagrams in each class of words of the same length. If you do not remember what is an anagram, we can check that in Wikipedia. So, an anagram is a word or phrase formed by rearranging the letters of a different word, typically using all the original letters exactly once. For example, silent and listen. This is an example of an anagram. So the program that I have described here is going to check the list of words of the dictionary file, separate the words into classes of words with the same length, and for each class of words of the same length, it's going to find all the anagrams. And in the end, the program will print the total number of anagrams in each class. Good. So this is the first thing we need to do. When we want to containerize an application, any application, not only this Python application for data analysis, when we want to containerize any application, the first thing we need to do is to understand the application, understand the program. There is no need for us to be developers. Typically, this task is performed by a DevOps. So a DevOps is a person who has knowledge both of operations and development, but does not need to be the original developer. So when we're given an application developed by another team, the first thing we need to do if we want to containerize that application is to understand the application. As I said, the most important line is line number 17, because line number 17 specifies where is the location of the file that we're going to use as a dictionary file. The other important line from a DevOps perspective is the last one, line 63, because it says that it's going to print the result. It's going to print the number of anagrams for each class of words. So these two lines, 17 specifying the location of the dictionary file. And this line 63, specifying what's going to be the output of the program, are the most important lines that we need to check to containerize our application. Obviously, for a different use case, it will be a different case. So that for any other application, maybe written in Java, maybe written in C++, you need to check the code and see what are the important components of that code in order to containerize your application. In this case, as I said, the most important part of the code are the location of the dictionary file and the output of the program. Well, given that information, go back to the program. So we have the data folder with the dictionary file called words.txt, the source code with the Python script that is going to extract that information from the words.txt file. And that's it. With this information is more than enough to containerize our application. The first thing we need to do is to create a branch. I'm going to create a branch called Docker from the main branch. And in this branch, I am going to create the necessary files to containerize my application. The most important file that I need to create is Docker file. I need to create a Docker file because the Docker file will be responsible to encapsulate the code, to encapsulate the software into a Docker image. Then that Docker image will be deployed and executed as a container. So I will run my Docker image. I will instantiate my Docker image in a container, in a Docker container. But first of all, I need to create my Docker image. And for that purpose, I will use what is called a Docker file. So I will add a new file. I will create a new file and I will call it Docker file. It is very important that the first D is capital letter. This is the standard name of the Docker file. Now I'm going to paste the content of my Docker file. This is my Docker file. I'm going to explain to you now the lines of my Docker file. The first line from will download a basic Docker image that will contain Python. So this Docker image, Python::Alpine, is a Docker image containing Alpine operating system. That is a very tiny operating system, a tiny Linux operating system based in Debian that contains Python. Then the next step, line number 2, is to copy the source code anagrams.py into the Docker image. So for that purpose, I will use the copy instruction of the Docker file that will copy from the local system in the folder src. It will copy the Python script anagrams.py into the Docker image with the name script.py. So it will change the name from anagrams.py into script.py so as to be more general. In the third step, I'm going to create a volume. Why I'm going to create a volume? Because I do not want to hardcode my Docker image containing the dictionary file. Instead of that, I will place my dictionary file in an external volume, in a separate storage. That is the purpose of creating a volume. So that I will have 3 Docker objects here. I will have my Docker image that will contain only Python, Alpine, and my Python script. The Docker container that will be the instantiation of that Docker image, and the Docker volume that will be an external storage, a separate storage to look where to store the dictionary file. So I will have three components here: the Docker container, the Docker image, and the Docker volume. The Docker container will be the instance of my Docker image. The Docker image will contain Python Alpine together with the Python script, and the Docker volume will contain the dictionary file. I'm going to give, I'm freely to give any name to the volume, to the external volume, but what I'm writing here, /words.txt, is the path inside the container. This is not the name of the volume. It's not the name of the external path of the volume. It is the path of the volume inside the container. So this is important. To write line number 3, I need to check the source code. So if I go back to the source code, if we examine the Python script of the source code, anagrams.py, remember line number 17. Line number 17 specifies the location where the Python script will try to find the dictionary file, words.txt. So this is the location that I need to write in line number 3. So line number 3 is actually connected to line number 17 of the Python script. So we need to understand the software. We need to understand the source code before trying to write our Docker file. Because without this knowledge, without understanding line number 17, it is impossible to correctly specify the volume written in line number 3 of the Docker file. Good. Now we will define the entry point and the CMD. The entry point and the CMD will just specify the binary that I want to run when I execute my Docker image. So when I instantiate my Docker image, when I run my Docker image, it will run Python and as an argument, a script.py, that is the name of my Python script. So Python script.py will be the final command that will be running when I instantiate my Docker image. Good, so let's save the Docker file. Excellent. Now that I have created Docker file, it is a good idea to create a Docker ignore. Why? Because when I'm going to build my Docker image with this Docker file, the Docker file is located in what is called the build context. And the build context will contain all the paths, all the relative paths in the same folder, so that it will use the data folder, the source folder, and all these files to create a Docker image. As I do not want to create a Docker image that contains the dictionary file, it is pointless to use the data folder when trying to create the Docker image. Because in the Docker file, I'm not going to copy the content of the data folder. I'm just going to copy the content of the source code. So it is pointless to include the data folder in the building process. So what I should do is to create a Docker ignore file so as to ignore the data folder in the process of building my Docker image. For that purpose, I'm going to add a new file and I will call it .docker ignore. The syntax is very similar to .gitignore. And here I will place the name of the folder that I want to ignore. In this case, data. So I will ignore the data folder. So when I try to build my Docker image, that will not, the build process will not include the data folder. Will include only the source folder, the Docker file, the license, and the README. Good, very good. Now let us continue. this will create my Docker image. Let us try it. Let us try that it works. So for that purpose, I will open a terminal in Cloud Shell. The address is shell.cloud.google.com. And here, first thing I'm going to do is to clone my repository. This is the repository that I'm going to clone, Academia Online /anagrams. And I only need to clone this branch, Docker branch. It's not necessary to clone all the repository. So here I am. I'm going to jump to the test folder. And here I'm going to clone this repository in this address, github.com/academiaonline/anagrams. But as I said, I only need one branch. So I will put the option, the flag single branch, and I will specify which branch I want to download, Docker branch. So here it is. This is my anagrams code with all the files that I have. That is the words.txt in the data folder. That is my dictionary file, the Docker file, the source code containing anagrams.py. That is my Python script for data analysis, and the license and the README file. So I'm going to show you now how I would create a Docker image from here. For example, I would run the command docker build. Then I will need to specify a name for the image that I am going to create. Let us say, for example, that I want to call it test image. And then I need to specify the location, the path of the build context. The build context is the folder where Dockerfile is located and also the rest of the files needed for the build process. In my case, I need the Docker file, but also I need the source code with a Python script. Everything is located in the folder anagrams. That's why I'm going to specify here that in the folder anagrams is my build context that contains my Docker file and also my Python script. Let us check it first. So remember, if I check the content of anagrams, I have my data folder with the dictionary file that I need to copy. Well, I do not need to copy. I need to copy only the source folder with anagrams.py and my Docker file. That is the principal things that I need for my build process. That is my build context. So not to include the data folder, I have already created the Docker ignore. I can check the content of the Docker ignore here. So data folder will not be included in the build context. Now I can run my command docker build -t, the name that I want to give to this image, and the path of the folder with the build context. Let us see the result. Now it will download the Python Alpine base image, and on top of that base image, it will copy. As you can see here, it has downloaded the Python Alpine image, the base image. From that image, it has copied the source code into the Docker image, as you can see here. And also it has created a volume, words.txt, and then specified the entry point and the CMD, so as to run Python script.py so that it will run my Python script when I instantiate the Docker image running a container. So I have already my Docker image. Let us check Docker image ls. There it is, my Docker image. Test-image latest. And Python Alpine is the base image. So I have my base image and my Docker image. Now I can run my container. So I just need to say Docker run, uh, Docker run, and the name of my Docker image, that is test-image. But before running that image, I need to specify the location of the dictionary file, because the dictionary file is not hard-coded inside the Docker image. So the dictionary file is supposed to be in an external storage. In an external storage that will be mounted in the location words.txt inside the container. So before running my application, I need to specify the location of the dictionary file. For that purpose, I will use the flag -v. So -v, and then the location of my dictionary file is what I need to run my Docker image. For that purpose, I will specify the location is in anagrams dash data dash words txt. This is the file that I want to mount inside the container, the external file with the dictionary file that I want to mount inside the container. In which location? Well, now remember the code words.txt and the Docker file. Let's have a look at the Docker file again and see that this is the location inside the container where I have to mount my dictionary file. So here I have to specify words.txt. Words.txt. So at the left of the instruction, I have the external path of the external storage that I'm going to mount inside the container. The right of the column, at the right of the column, I specify the path inside the container /words.txt, and at the left, I specify the location of the file outside in the host machine. I run this command, and the result will give me, as expected, it will print the output, that is the number of anagrams per class of words of the same length. So in this case, for example, I have 80 anagrams of 2 characters, 805 anagrams of 3 characters, 4,497 anagrams for words of 5 characters of length, etc. So I have checked that the containerized application works. Now I promise to explain to you how to implement continuous integration with GitHub Actions. For that purpose, let's go back to our GitHub repository, and here I'm going to add a new file. In this case, the file has a different name that needs to be like this exactly. .github, this is important, .github /workflows/ and now the name that you want. For example, I will choose a name, for example, ci.yaml, but it can be any name. But here you choose the name of the pipeline, but the folders need to be exactly like that. .github /workflows/ then the name of the pipeline. So let us paste the content of the pipeline that I'm going to use to implement continuous integration with the help of GitHub Actions. So this is the file. First, in the first line, we specify a name for the pipeline. For example, CI in capital letters. It can be the name that you wish. The second line on will specify when we'll launch the pipeline. In this case, the pipeline will be launched every time we push a commit to the following branch. I will specify the name of my branch, that is Docker. So anytime I push a commit to the Docker branch, it will run the pipeline. The sixth line specifies the jobs of the pipeline. In this case, I will have just one job, and I will call it Docker. This Docker job of the pipeline will run on an Ubuntu machine. This Ubuntu machine is provided for free by GitHub. So GitHub Actions will provide free of charge an Ubuntu virtual machine. You can choose the type of machine. You can choose an Ubuntu machine with version 18. You can also choose Ubuntu 20. You can also choose a Mac machine or a Windows machine. So you have a list of different machines to test your code. In my case, I'm going to use Ubuntu version 18. The next line, steps, will specify the steps of the job. In this case, I have two steps. The first one, called code checkout, will clone the repository, will be equivalent to this step here, git clone. In this step that you can see here in line 502, I have specified that I wanted to clone the Git repository in the location github.com academiaonline/anagrams single branch Docker. This is what is going to happen when you use this step code checkout, because it uses this API actions/checkout version 2 that will clone the code of your branch in the Ubuntu machine. So after step code checkout, after this step is finished, when we jump to line number 12, we already have all our source code checked out in the Ubuntu machine, and we are located in the relative path in the root file in the root folder of that repository. So it means that anagrams, we will be inside the folder anagrams when that step is finished. We will be here. The path will be this one. So we will have Docker file in the same folder, and we will have in the relative path the data and the source folder. So that in step number 12, that I called test image, we will be able to run different commands that will be run inside this folder, inside the anagram folder from the Docker branch. Now I have decided to specify environment variables. Line 13 specifies environment variables. I will explain to you later these environment variables. First, let's check the next property, that is run. Run will specify the commands that I want to run in that Ubuntu machine. The first command is to build my Docker image. As you can see here, the same as I did here in the shell cloud, the first thing I have to do is docker build -t and the name of the image that I want to create. So in this case, docker build -t test image, and I will specify :ci because it is my continuous integration testing image. Then remember that the next thing I have to do is specify the location of the. What happens now is that after the previous step code checkout, what happens is that the build context, I am inside the build context. I am inside anagrams folder. So it means that my location is the exact location of the build context. The current path is the build context. So that's why I will specify with this option. $pwd will give me the current location, and that will be exactly the build context. In some cases, you can put just a dot. I just wanted to explain to you that that dot means the current location, the current path. The thing is that in this field, you need to specify the location of the build context. Let it be a dot, let it be a folder, like in this case what's relative folder, and in this case is $pwd, that means the current path. A dot would have the same purpose, but instead of a dot, I have written $pwd. $pwd is an environment variable that specifies my current location. For example, if I say here pwd, it will give me the location inside my terminal. Good. Now, as before, Docker run will run my container. So I want to test my application, so I want to test the container. For that purpose, I will run the command docker run. Remember that I needed to specify the flag -v because I need to specify the location of the dictionary file because it is supposed to be in an external storage as specified in the Docker file. This line number 3 says that the dictionary file is in an external storage in a Docker volume. Here I specify the location of that volume. The left part of the instruction is the external location of the volume on the host machine. And the right part of the instruction is the location inside the container. So I have to specify both locations, outside the container and inside the container. Outside the container, I need, first of all, my current location, my current path, and then the relative path of the volume. As we already know, it is data words.txt. We can check it here. It is data. And then if I click in data, data words.txt is the location of my dictionary file. That's why I put here in line number 15 that the volume path in the host machine is data/words.txt. Obviously, I need to put first my current path because this is a relative path. So I need to put here first the absolute path. Then to the right of the instruction, I need to specify the path of the volume inside the container. Where is it going to be mounted inside the container? As it is specified in the Docker file, it is in /words.txt. /words.txt, this is what I've written in line 16. Remember that it was justified because line 17 said that my Python script is going to check for a file located in words.txt. Now that I have specified the location of the volume, the characteristics of my volume, the specifications of my volume, I can use the flag -d to run the container in the background in detached mode. I can specify also a name for my container. Let's name it test-container. And then it's necessary to specify the name of the image that I want to instantiate. The Docker image will be the same Docker image that I have just created in the previous command. In line number 18, I created an image called test_image:ci for continuous integration. And this is the image that I want to test running it as a container. After the image is running, I can check the logs of the container. If the logs are correct, then the test will be fine. Otherwise, the test will fail. So I have created an infinite loop here with a while true condition that will run every 10 seconds a check of the logs. With the command docker logs, I will check the logs of the test container every 10 seconds. And I will grab if I can find the pattern. So output pattern is the pattern that I want to find in the output of the logs of my container. I have defined that value in the environment variable, output pattern, and I have written curly bracket 1 colon. Why have I written this? Because if you check the output of the command, the output of my application, the output of my Python script is going to write a list with the number defining the class of the word depending on the length, that is 1 character, 2 characters, 3 characters, etc. And then it will print the number of anagrams. So the output of my Python script should write something like this, curly bracket 1 colon, etc. This is why I have put in my pattern curly bracket 1 colon, etc. Well, obviously this output pattern satisfies this use case, but any other application with any other container will need to be examined, and you will need to check what is the desired output pattern. For example, if it's a web server, maybe you're looking for something like welcome to Nginx, or maybe you're searching for something different. It will depend on your use case and your application. As I said, this Python script will print the number of anagrams per class of word depending on the length of the word. That's why for me it's enough to check for an output like this, curly bracket 1 colon. That means that the application worked fine. Good, excellent. So I could specify more details in my test. Well, this test is enough for this case, but you could specify different details for your unit test. Once the Docker logs finds this pattern, this double ampersand will break the loop and the output will be a successful exit, and the continuous integration test will give me a successful positive output, so that my application is successfully passing the continuous integration test. So let's commit the file, but before committing the file, well, let's commit the file, and then we will add a new feature. If we commit the file, that will trigger the pipeline, because as we can see in line number 2, on push of any commit to the Docker branch, that will trigger the pipeline. So that will run the Docker job that will run on an Ubuntu machine with the following steps. First, it will check out the code, and then it will test the image with these commands: Docker build, Docker run, and then the infinite loop to check Docker logs. We need to wait until the pipeline is finished. That will take a few seconds. And in the end, we will receive a green badge or a red badge. This color, this orange color, means that the pipeline is now up and running. If I click here, I can see that the pipeline is still waiting to run the check. If I click in details, I will see more details of the pipeline. It is working on it. So I can wait. Here you can see the commit that I have pushed that is being tested by the pipeline. Once the pipeline is finished, it will have, if it's successful, I will see a green tick or a red tick, depending on the result of the pipeline. Let's go back to actions. If I click in the job, I can see the output. It is waiting. Normally it takes just a few seconds, but as it is a free resource, you have to be patient. When there is any machine available, it will start the pipeline. It is taking really long. Normally it is not so long. Meanwhile, we're going to learn something else. When the pipeline is successful, I will receive a badge, a green badge, meaning that I have passed my continuous integration test. And I can use that badge to put it in the README file. So I can add it here in the README. I can add a badge for the result of the pipeline. I'm going to paste the badge that I going to receive when the pipeline finishes, obviously. So this is how to get the batch. I need to specify the URL of my repository, the path of the workflows, the name of the pipeline, and then batch.svg question mark and the name of the branch, in this case, Docker. Very good. Now, as we can see here, we're passing the continuous integration because the continuous integration test has been successful. Let us check the results of the continuous integration test. For that purpose, we can go to Actions, or we can click here in the green tick. If we click here in the green tick, we can see the details of our continuous integration action. So this is the result of the test. We can click here to view the raw logs. Let's check the raw logs. We can see here how GitHub Actions is preparing the virtual environment with a virtual machine with Ubuntu 18. Now with checkout, it is downloading Academia Online anagrams, the branch Docker. And then after the branch Docker has been correctly downloaded, it will start with the code to test. So it will run the following commands. First, it will run Docker build, then it will run Docker run, and then it will run Docker logs. In Docker build, it is running here. It is downloading first the Python Alpine image, then it is copying the Python script into the Docker image. Then it is specifying to create an external storage for the dictionary file, and then it is specifying Python script.py as the command to be run when I run that image. After the Docker build has been correctly finished, then I will run the Docker run, and the Docker run will give me as the output of the number of anagrams per class of words. Then I need to run an infinite loop to check that my result of the logs of my container are correct. This is running this command, docker logs test container. That will check the output that it will contain curly bracket 1 colon that will break the loop. And the process will be finished with a successful output. This is how I can get a green tick for this commit. If I go back to the code, and I go to the Docker branch, and I can see that in my README file, I have a CI passing green badge for my continuous integration test that is passing. Good. Now, this is continuous integration with GitHub Actions. How can I implement continuous delivery with Dockerhub? For that purpose, we need to connect Dockerhub with GitHub. So that to implement continuous delivery in Dockerhub, we need to connect our Dockerhub account with our GitHub account. In this case, our Dockerhub repository with our GitHub repository. Let us create a repository called anagrams in my account of Dockerhub. So I have an account in Dockerhub that is Academia Online, and I will create a repository called anagrams. And I will use this repository to store the Docker images created with the code specified in my GitHub account, in my GitHub repository. So I will create a public repository called anagrams, Academia Online /anagrams. And now in the builds, if I go to builds, I will link this Dockerhub repository to store Docker images with my GitHub repository that contains the source code that I want to encapsulate in my Docker image. I select Academia Online and I select the repository anagrams. This will connect my source code of Academia Online /anagrams to my Docker image academyonline/anagrams with the same name. Now I have to specify which is the branch that I want to, that contains the code that I want to encapsulate in my Docker image. The branch will be Docker. That is the branch that I have created with the Docker file. Then I can specify here the tag for the Docker image, the location of the Docker file. It is Docker file in the root folder. And this is the build context. The build context is, in this case, is just the root folder, because here the build context is where Docker file is located. And this is in the root folder of my repository anagrams. So here I just have to place a slash, is enough. If I save and build, that will create a Docker image with that content. It is in a pending state. It is a free service, and we have to wait. We have to be patient. As soon as there is some infrastructure available, it will start with the build process to create our Docker image and store it in Dockerhub. I can click in the build process to see how it is going. It has been created a few seconds ago. Has the build context is this commit 95C8DEAE. I can check that this is the last commit here that was successful, 95C8DEA. It's the same commit that is going to be built in Dockerhub. So I have continuous integration to check that the commit is successful, and continuous delivery, building a Docker image that will be publicly available to be deployed in any environment, let it be development environment or in a production environment. This is the source code, academyonline/anagrams. As you can see here, this icon represents GitHub. So this is the source code in GitHub. And this is my Docker image registry in Dockerhub. So it is still not ready, nothing is available yet. The README file, I need to refresh the page every while to check if the process is or not successful. Not yet, we have to be patient. So go back to the general dashboard. So here we will see how the build process is going on. When it is finished, we will be able to download our images. Let's check again the build process, how it is going. Here we can see that it is taking 2 minutes ago. It's queued 1 minute. It is in progress. Soon it will be ready. And we will have our Docker image based in our source code. There is no information yet available. What we're going to do now, meanwhile it is creating the Docker image, we're going to prepare for the deployment in production. We're going to do a very basic example so that we're going to use Docker Compose instead of Kubernetes. Maybe in another video, I will teach you how to use Kubernetes to deploy in production, but in this case, we're going to deploy with Docker Compose to make it simple. For that purpose, I'm going to create a Docker Compose YAML file to deploy my application in a production environment or in a testing environment, as I wish. I will have a Docker image available, and this Docker image will be capable to be deployed in any environment. So let's configure the file to use Docker Compose to deploy our application. And as I said, maybe in another video, I will teach you how to use Kubernetes instead. So for that purpose, I will create a Docker Compose YAML file. So let us create a new file with the name Docker Compose.yaml with the following content. Services, A name of the service Python, whatever name is okay. This property is necessary, services, and here I put the name of the service, whatever name is okay. In this case, Python is good. Now the next property of the service is the image that I'm going to deploy. This path needs to be the same path of the image that is going to be in Dockerhub. So if we go to Dockerhub and I go to General and I go to Public View, I can get the full path to download my Docker image. You see, Docker pulled Academia Online /anagrams. That will be the location of my image, Academia Online /anagrams. So this is the same that needs to be written here. Here I am writing latest because by default, it is the same. You can put, it's equivalent to write Academia Online /anagrams than Academia Online /anagrams latest, because by default, Docker will put the tag latest to any image without a tag. So any image without a tag will be equivalent to put latest. I put latest to specify better the name of the image. In the line number 4, I say restart no. It means that I do not want to restart the container because this container is a Python application to analyze the dictionary file. Once the dictionary file has been analyzed, it will print in the output the number of anagrams per class of words, and I do not want to repeat the process over and over. Just once is more than enough. That's why I'm saying do not restart the container once it is finished. As before, I need to specify the volumes because remember that the dictionary file is not located inside the Docker image. It's not hard-coded inside the Docker image. So the dictionary file will be externalized, and I need to specify the location, the external location of the dictionary file that will be, as I said before, the relative path data folder /words.txt, and to the right of the configuration, I have to specify the internal path inside the container where this external volume is going to be mounted inside the container, that is /words.txt. And then the version of the Docker Compose that is 2.0, because if you want to use Docker Compose, you need to use version 2. Version 3 is only available for Docker Swarm. Good, so now I commit directly to the Docker branch. Now I can just use it. So let's see if the image is already available. So as we can see here in builds, the image is already available. The tags was pushed 4 minutes ago, latest. And in the details of the builds, I can see more details of the build. Clicking here, I can see details of the build process, like the build logs, how it was again running Docker build to download, first download the Python Alpine base image, then copy the source code, the Python script into the Docker image, then how to create the volume to externalize the dictionary file, to specify the entry point and the CMD to run Python script.py when I run the container, and then running the container. That's it. So, and then pushing the final Docker image into my account in Dockerhub. Index.docker.io is the URL where I have to push my image. Index.docker.io /Academia Online /anagrams latest would be the full path, the full qualified domain name of the location of my image. If I click here in Docker file, I can see the Docker file that has been used to create that image, to build that image, and the README specifies any instructions about this application, and I can see the green badge that the application is passing continuous integration. So now my Docker image is publicly available. So anyone running this command, docker push let's see the public view. Here, this is what anyone, because the previous view was for an authenticated user. Now this is the public view for anyone accessing this repository in dockerhub.com academy online /anagrams. So this command, docker pull academy online /anagrams, is the command that anyone can use to download the image. For example, if I run this command here, I will pull that image from the public repository, as anyone else can do. Now, if I want to deploy my application with Docker Compose, what I have to do is go to the repository anagrams, git pull, because here I cannot see the docker compose.yaml because I have created it afterwards. So I need to git pull to download the recently created docker compose.yaml. Now I have my docker compose YAML here. Let's see the content. So first line is the definition of the services. The first service is Python. The property image will specify what is the name of the image that I want to download. No restart, that means that when the container finishes, I do not want to restart it. And the location of the volume. The dictionary file will be located in this path. As you can see here, this is the path of the dictionary volume, and /words.txt is the location inside the container where this volume is going to be mounted. And version 2.0, the version of Docker Compose that I want to use. Now, if I want to run the application, I just need to run Docker Compose up, and that will run the container. And there you have the result. The result, the output of the container is the list of classes of words, depending on the length, how many characters has each word, and then how many anagrams can we get with that class of words. That is the output of the Python script that will analyze the data. If I want to stop the containers, just Docker Compose down will stop the application. So this Docker Hub image is publicly available and can be deployed in any environment. As I have done here, this environment can be production, can be testing, can be QA. The Docker image is here publicly available. Of course, you can, instead of a public repository, you can have a private repository depending on your use case and on your needs. Good. So thank you very much. I have taught you in this video how you can use Docker to containerize a Python application used for data analysis. I have also explained to you how you can use GitHub Actions to prepare a continuous integration pipeline to get the green badge. And after you get the green badge, how to push that Docker image in Docker Hub so as to have continuous delivery. That image from continuous delivery can be deployed in any environment. It can be testing environment or it can be production environment. Only this command will be needed to be used. Docker pull academy online /anagrams. Well, thank you very much. Next video, maybe we will learn how to use Kubernetes to deploy instead of this basic Docker Compose example. Kubernetes and also Docker Swarm, two great orchestrators to deploy your applications in a real production environment. Thank you very much for listening and see you in the next video.